In Fabric, security is not a one-time setup. It is an operating discipline, hardening nodes, protecting identities and keys, securing Kubernetes and pipelines, and modeling threats before they become incidents. That is the mindset we will build in this module. You already have the core pieces: Fabric architecture, smart contracts, integration, deployment, and automation. Now the focus shifts to operations. Once the network is running, how do we protect identities, infrastructure, and daily processes from real threats? Fabric hardening works best as an operating loop, not a setup checklist. You provision identities and policies, monitor behavior, rotate certificates and secrets, revoke access when trust changes, audit evidence, and recover quickly after incidents. Each layer matters: MSPs, TLS, keys, Kubernetes, networks, DevOps controls, and governance. The goal is defense in depth, where least privilege and segmentation reduce blast radius, and security stays aligned with compliance every day. Fabric treats identity as a chain of trust. Certificate authorities issue enrollment certificates to users, peers, orderers, and admins. Those certificates prove who is signing a transaction or governance action. The MSP configuration defines which CAs are trusted, which admins are valid, and which organizational units map to roles. Local MSPs identify individual nodes, while channel MSPs define trust for an organization on a channel. If this is misconfigured, access, policy enforcement, or availability can break. TLS protects every Fabric conversation: clients to gateways, peers to orderers, CAs to admins, and services across cloud boundaries. It encrypts traffic and confirms that each endpoint is who it claims to be. In production, use mutual TLS, so components authenticate each other. Also confirm that certificate SANs match real DNS names, Kubernetes services, ingress routes, and load balancers. Expired certificates, weak ciphers, or exposed endpoints can quickly become outages or attack paths. Certificates are not set and forget assets. In Fabric, every enrollment, TLS, CA, admin, peer, orderer, and client certificate needs an owner and an expiration watch. Start renewal well before the deadline, using 90, 60, 30, and 7-day checkpoints. Rotate certificates when infrastructure, CAs, personnel, or trust assumptions change. Then update MSP material carefully, deploy in a controlled order, and validate channel configuration and node communication before production traffic depends on it. When an identity is compromised, speed matters, but control matters just as much. First, contain the risk and preserve evidence. Then revoke the certificate with a CRL, get the required governance approval, and update the MSP and channel configuration so every organization enforces the change. Do not stop with Fabric credentials. Disable related application keys, Kubernetes secrets, and CI/CD tokens. Finally, confirm that access is blocked and keep audit records for compliance. Private keys are the authority behind Fabric identities, signed transactions, and administrative changes. Treat them like production crown jewels. Store them in HSMs, Cloud KMS, or tightly controlled secret stores. Then limit who can use them. Security teams issue certificates, platform teams operate infrastructure, and blockchain admins manage network actions. No single role should control everything. Add approvals, audit logging, and planned rotation, so compromise risk stays contained. The practical goal is to keep Fabric private keys out of containers and laptops. Dedicated HSMs provide the strongest tamper resistance and compliance story, but they add cost, setup effort, and PKCS number 11 integration work. Cloud KMS reduces operational burden, but still requires careful checks for latency, signing support, and export rules. Many teams use a hybrid model: protect root and admin keys strongly, while handling lower-risk operational secrets with Kubernetes native controls. In Kubernetes, cluster permissions can become blockchain permissions. Anyone who can read secrets may steal Fabric identities. Anyone who can exec into pods, port forward, view sensitive logs, or change deployments and ingress can intercept traffic or disrupt availability. Apply least privilege to humans, service accounts, operators, and CI/CD. Separate organizations and environments with namespaces. Tie access to enterprise identity and MFA, and treat audit logs as control evidence. Container security has two connected gates. Before deployment, reduce supply chain risk. Use trusted base images, scan for vulnerabilities, keep an SBOM, and sign what is approved. At admission time, block images or pod specs that violate policy. After deployment, limit blast radius with non-root users, read-only file systems, and minimal Linux capabilities. Then monitor runtime behavior for unusual processes, network connections, or file access. Prevention and detection need to work together. Kubernetes should enforce the trust boundaries around Fabric, not just run the pods. Network policies should allow only required paths, peers to orderers, gateways to peers, CAs to approved clients, and monitoring to approved targets. Everything else should be denied by default, especially admin, metrics, and operations endpoints. Apply the same discipline to secrets. Encrypt them, limit access, and prefer KMS external vaults or sealed secrets. Review every ingress, DNS, firewall, and load balancer change. Threat modeling begins by naming what must be protected: keys, certificates, ledger data, private data, chain code packages, admin credentials, and APIs. Next, map where trust changes across organizations, clusters, namespaces, clouds, pipelines, and external systems. Include internal admins, malicious insiders, compromised applications, external attackers, and supply chain threats. For each boundary, ask stride-style questions. Who could spoof, tamper, disclose data, deny service, or escalate privileges? Then prioritize mitigations by likelihood, impact, regulatory exposure, and business criticality. Practical Fabric security turns likely incidents into controlled decisions. For a compromised identity, prevention includes MFA, HSM or KMS protection, certificate rotation, and rapid revocation, while detection comes from audit alerts. Insider risk calls for least privilege, separation of duties, approvals, and immutable logs. Policy mistakes need peer review, automated checks, and governance. Exposed APIs need TLS, authentication, network controls, rate limits, monitoring, and a clear response owner. Strong Fabric operations start with trusted identities, correct MSP configuration, secure TLS, and disciplined certificate lifecycle management. Protect private keys and admin access with auditability and separation of duties. Kubernetes controls and threat modeling extend that protection across the platform. Next, we will build on this foundation for resilience and scale.